purpose of this assignment is to study the RLC resonance circuit analysis by using MATLAB. Therefore, in this assignment, we are required to find out the current transfer function and also determine the transfer function for the equation. Now, we will determine the current transfer function IS. So, if we have a look at the equation, at the circuit given, the value of Vm is 10 sine omega t, and we can see there is R, L and C. The value of R, L and C can be changed according to our value, according to the value that we want to pick, and that is the T domain circuit. Firstly, we change it to the S domain circuit and we find Z total, which is R plus 1 over SC plus SL. Then we use Ohm's law, which is V equal to IZ. Then only we can find the current transfer function IS equal to Vm over Z.
Okay, now we go with Q1. Okay, we use MATLAB software to solve the equation. Okay, firstly we insert the coding. This is the coding for the MATLAB for Q1, and we choose the value of R, L and C. R is 6 ohm, L is 1 Henry and C is 1 Farad. Okay, then we run the coding for the MATLAB and then we will get the answer. Okay, this is the answer. Firstly, we get the omega node, or known as frequency resonant, is 1. We get the quality factor Q is 0.1667 and we get the bandwidth. The bandwidth is 6. Okay, after that we will get the waveform. Okay, this is the waveform for Q1. X axis for the waveform is 0.9549 and Y axis is 1.6666. Okay, next, after we settle with the MATLAB, then we want to prove the equation. Therefore, we will use Maple to solve the equation. Okay, this is the equation. Okay, what we do in Maple, we insert the value of R, L and C. R is 6 ohm, C is 1 Farad and L is 1 Henry. And after that, we just insert the value in the formula, in the equation, then we will get the answer. Okay, this is the answer for the Maple. Then as we can see, the answer, for example, the frequency resonant omega node is equal to 1. It is same goes to the answer in the MATLAB. Q is 1 over 6 or can be seen as 0.1667 and the bandwidth is 6. And in the MATLAB also we get the bandwidth is equal to 6. We proceed with Q2. Okay, this is the coding for the Q2. Okay, we just change the value of R, which we pick R is equal to 4 ohms. Then we run the coding. After we run the coding, then we will get the answer. Okay, this is the answer. The omega node of frequency resonant is equal to 1. The quality factor Q is 0.25 and the bandwidth is equal to 4. Okay, and lastly, this is the waveform for Q2. X axis for the waveform is 1.009 and Y is equal to 2.5. Okay, this is for MATLAB. Next, we proceed with the Maple equation. Okay, what we get for the Maple, okay, this is the value. R is 4 ohm, C is 1 Farad and L is 1 Farad. And we just insert the value for R, L and C in the formula. then we will get the answer. Okay, this is the answer. And what can we see from the answer? The frequency resonant or omega node is equal to 1, which is the same goes to the answer in the MATLAB. And the Q quality factor is 1/4, which is also same with the MATLAB, which is 0.25. And the last one is bandwidth. The bandwidth that we get in the Maple is equal to 4. Still the same answer we get in the MATLAB. Okay, the last one we proceed with Q3. Okay, this is the coding. We insert the coding for Q3. We just change the value of R. We change the value to 2 ohm. Okay, after we run the coding, then we will get the answer. Okay, this is the answer. The omega node of frequency resonance is equal to 1. The quality factor Q is 0.5 and the bandwidth is 2. And after that, we will see the waveform. Okay, this is the waveform for Q3. What we get for x-axis is equal to 1.028 and y is equal to 4.998. Okay, this is for MATLAB for Q3. Then after that, we proceed with the MATLAB for Q3. Okay, this is the MATLAB for Q3. We just insert the value. R is 2 ohm, C is 1 farad, and L is 1 Henry. After that, we just insert the value of RLC in the formula stated here, and then we will get the answer. And as you can see, the answer for the omega node or the frequency resonance is equal to 1. Same goes with the answer in the MATLAB. And secondly is the quality factor is equal to 1/2, which is also equal to which is also same with the answer in the MATLAB, which is 0.5. And the last one is the bandwidth. Bandwidth what we get in MATLAB is equal to 2, and we get the same answer in the Maple. Therefore, we can conclude that in Q3 we also get the same answer for Maple and the MATLAB. Next, the last one, we proceed with the comparison for Q1, Q2 and also Q3. Okay, firstly, for the comparison, we would like to state that we use the same value of LNC for all the equation, for all the Q1, Q2 and Q3, which is the value of L is equal to 1 Henry and the value of C is equal to 1 farad. But the difference is we use the different value of resistance. What we use for the Q1 we use 6 ohm, Q2 we use 4 ohm, and Q3 we use 2 ohm. And secondly, for the greatest sensitivity, we have to know that the lower value of bandwidth, we can decide it as a greater sensitivity. Therefore, from all the 3 quality factor that we get, we can say that Q3 have the greatest sensitivity, while Q2 is medium sensitivity and Q1 is the least sensitivity.